Hi friends, I am Indrajeet Jain. I completed my Masters in Structures and I found out teaching. Today I will teach you Mechanics of Structures, in which we will cover some basic concept of shear force and bending moment. So while solving the numerical on this, first of all, we have to understand the concept of beam. Beam is an horizontal member supported along the length and subjected to transverse loading. There are three types of the beams that are simply supported, overhang, and cantilever. These three types of the beam are determinant beam, the beam which can be analyzed by the three conditions of equilibrium. Simply supported beam is the beam which is just raised on two supports. And for equilibrium condition or for determinacy, the one end must be hinge and other end must be roller. Overhang beam. This is a simply supported beam only, but in which the beam will be extended beyond the support. So the beam which is projected beyond the support, such beam is called as simply supported beam with overhang or overhang beam. And next is cantilever beam. One end is fixed and other end is free. Such type of beam is called as cantilever beam. Then next is the definition of shear force. The shear force is the algebraic sum of all the vertical unbalanced forces either left or right of the section. Simply, we'll take the summation of all the forces, all vertical unbalanced forces, just left of the section or right of the section. For simplifying our numerical and to avoid the confusion, we will generally consider left side of the section for some initial numeric. The sign convention for shear force is that on the left side of the section, upward positive, and on the right side of the section, downward positive. So here, this is the sign convention on the left side of section, upward positive, on the right side of section, downward positive. Now, just opposite to this, for negative shear force, on the left side of section, downward, negative, and on the right side of section, upward, positive. Now, next concept is bending moment. Bending moment again is the algebraic sum of all the moment of the forces either left or right of the section. So summation of bending moment about any section xx is equal to bending moment about any section xx is equal to summation of moment of all forces either left or right of the section. So here we are considered left of the section. Sign conventions, that is sagging bending moment is considered as a positive and hogging bending moment is considered as a negative. The sagging bending moment in which on the left side of the section clockwise is positive and on the right side of the section anti-clockwise positive. In sagging bending moment on the left side of the section clockwise is positive. And in hogging moment on the left side of the section anti-clockwise is negative. So in hogging sagging section, left side of the section clockwise is positive. In hogging section, left side of the section anti-clockwise is positive. And the sign will be on the right side will be opposite. Now let will apply this concept for solving the numerical. Let us have the numerical simply supported beam is supported and loaded as shown in figure. Determine the shear force and bending moment. Also draw shear force and bending moment diagram. So this is a numerical in which we have the beam of A, B, C, D, E. AB is 2 meter, BC is 2 meter, CD is 1 meter, and DE is 1.5 meter. The load at point B is 100 kiloton, at C is 200 kiloton, at D is equal to 150 kiloton. So while solving the numerical for shear force and bending moment, we have to first find out the support reactions. First step will be your support reaction. And support reaction, for solving the support reaction, we have the three conditions of equilibrium. Summation of moment about any point must be 0. Summation of all forces in y direction must be 0. And the summation of all the horizontal forces must be 0. We will apply the first condition. Summation of moment of all the forces about any point must be 0. So here, taking the moment about A, which is equal to 0, applying the condition of equilibrium. Clockwise is positive and anti-clockwise is negative. The sign clockwise is positive and anti-clockwise is negative. So force 400 Newton, the force 400 Newton, which produce a clockwise movement. Clear? It produces a clockwise movement. So 100 Newton into its perpendicular distance 2 meter will give us a moment of force to 100, moment of force of 100 Newton about A. Then we'll take the moment of force 200 Newton. Force into distance is a moment. This will again rotate in a clockwise and whose perpendicular distance from A is 4 meter. So here 200 into 4 meter is the moment. Next, then 150 Newton force with respect to A. The distance from A to D is 5 meter. The distance A to D is 5 meter and 150 into 5 is moment. Then after that, this reaction RE is rotated anti-clockwise and its perpendicular distance is 6.5. By this, you will get the support reaction RE. So after calculating this value, RE will be equal to 269.23 Newton. Then sign convention I explained, that is clockwise. Then summation of Fy, the another condition of equilibrium, upward positive and downward negative. So this is sign convention, upward positive, downward negative. So here RA support reaction at A, RA is upward, so upward positive. This 100 Newton is downward, downward negative. This 200 Newton is downward, negative. This 150 Newton is downward, negative. RE. So this is RE. So RE is upward, RE positive. So substituting the value of RE from above equation, value of RE from above equation, by substituting that, we'll get this equation. So we substitute the value of RE. And you get the value of RE is 180.77 kilonewton. So now the value of, so it is Newton, 180.77 Newton. So by this we will get the value of support reaction RA and RE. Now all the forces acting on this beam is known. Now we will calculate shear force. So next is shear force calculation. So for shear force calculation, we have written here the reaction at A, that is RA, what we have calculated, and here RE, we have calculated this value. So we have written here the value of RA, RE. Now for finding the shear force, we will just take the section at A, just left of the A and just right of the A. Then the section just left of B. So this is A left, this is A right. Similarly, this is B left and this is B right. Similarly, this is C left and this is C right. And so on. Same D left and D right. Clear? So like this, we take the section at various point. Now we have to find out shear force at each point. The sign convention for shear force on the left side of section, upward positive. On the left is the left side. Clear? This is left side of the section. This is section XX. So this is the left side of section, and on the left side of section, upward positive. And on the left side of section, downward will be negative. So here, the first is shear force at the left of A. This is section A. On the left side of this section, there is no forces. There is no forces on the left side of section. So shear force just left of A will get 0. There is no force on the left side of this section. So shear force at A left is 0. Now shear force at A right, shear force just right of A is equal to, see here, this is here shear right. And on the left side of this section, there is a upward force. And this upward force on the left side of section is 180.77, which we have taken over here. Clear? इसके बाद आप जाओगे नेक्स्ट सेक्शन पे, दैट सेक्शन इज बी लेफ्ट. इसके पहले हमने ए राइट देखा था और नाउ इट विल बी लेफ्ट. ए राइट और बी लेफ्ट के बीच में कोई लोडिंग नहीं है. इसके लेफ्ट में जो फोर्स है वही बी लेफ्ट के भी लेफ्ट में है. So your value will remain same as there is no change on the left side of A right and left side of B left. So there is no changes in the forces on the left of B as well as A right of A. Clear? The next is the section will be your B right. This is your section B right. See here, this is your section B right. And on this section B right, this is your section B right, just for shear force just right of the B. And we consider all the forces left side of the section. Now on the left side of section, left of B right, this is upward force and this one is downward force. So here leftward force, so this upward force 180 will be positive and this 100 Newton which is downward of the section is considered negative. The total will be 80.77. After this, then we'll go for the section C left. And as I explained you that there is no loading between B to C. So there is no change in your value of B right, left of B right or left of C left. So let us see C left, shear force at just left of the C, that will be remain same as B right because there is no loading between B and C. Now next is here C right, this particular section, and left of this C right there is an additional 200 Newton force which is downward. So we have taken the previous on the left side of this one 180, 100 downward and 200 downward. So 180 upward positive, 100 negative, 200 negative, and you got value is 119.23 minus 119.23 minus. After this, then we'll go for the section D left. The value at left side of the C right is remain same, the value of left side of D left. And let me see, the value will be same 119.23 because there is no loading again between C right and D left. Next section is D right. In D right, see here, the value 150 Newton downward is added. You can see the other all calculations are same. Only this downward 150 is added on the left side of D right. So we got a value at D right minus 269.23. Then D right, this D right and this E left. D right and E left. The value will remain same because on the left side of D right, whatever the summation of all the forces, same will be left side of the E left. Let us see same. See here the same value you will get. The same value will be there. Now after that, the last point is E right. Last point is E right. So when you take this section, E right, the previous value all will be added. And on the left side of this section, E right, there is a upward reaction. there is an upward reaction that is positive. So here you can see that there is an upward reaction which is 269.23, which is positive, and final output at 0. So like this, you can find out the shear force at various sections along the length of a beam at various sections. Now, how to draw the bending shear force diagram from this calculation? So we got the coordinate of A point C. This is your A, point A, just left and right. If it is A, then this is point B. We get the ordinate of point B. Then this is C. We'll get ordinate of point C. This is D. We'll get ordinate of point D. And this one, both are at E. We got the ordinate of point E. So whatever we calculate at A, 0 and 180. So see here in next slide, we'll check. This is your beam with shear force at various sections. The line AB, AE, which is of same length of your beam. Then you can see at A there is 0 and the other one is 180.7. The same value which we have taken earlier, see here, see here. These two are 0 and 180.7. Same value we have taken. And now second, you can see that 180 and plus 80. 180.77 and 80.7. There is a drop. So let us go for this one. You got A 0 and 180.7. At B, this is the point B. At B, you got two coordinates. The first one is 180.77 and second one you got 80.77. We'll join this point by a straight line if there is no different types of the loading, especially UDL or UVL. If there is no loading between 2 points, it will be represented by a horizontal line. Then, and this is all about B point. B point you got 180.77 and second one you got 80.77. Next we'll go for the C joint. This is C joint. C having two coordinates. The first one is 80.77. We mark here, and the second one is minus. This is minus 119.23. We mark here and join by a straight. Then after that, your next point is D, and at D point, the first value will remain 119.23, and second is the value 269.93 negative. Then next here, same value 269.23, and then the last is 0. Like this, you will get shear force and bending diagram. This one is positive above the reference axis and below the reference axis negative. So you will be able to find out shear force diagram like this. Next calculation is bending moment. Now, bending moment calculation. The same beam we have to consider. Bending moment. The definition of the moment is force into perpendicular distance. We'll take the bending moment at various sections A, B, C, D, and E. We'll take the bending moment at various sections A, B, C, D, and E. So the first one is consider moment on the left side of each section. Let me consider the section here. Let me consider section. Yeah, this is A. To consider section at A, on the left side of this section, there is no force. Clear? On the left side of this section, there is no force. So moment at A is equal to 0. Clear? The moment at A is equal to 0. Clear? moment at A is equal to 0. Now we'll take the bending moment at the next point, that is B point. This is your point B. On the left side of this section B, the force is 180.7 kilonewton upward on the left side of this section. Here, on the left side of this section, the force is 180 Newton, 180.77 kilonewton. This is, so it is clear. And this force produces a clockwise movement. It rotates clockwise. So here 180 into 2 is your moment. 180 into 2 will get a moment at point B. On the left side of point B, 100 Newton force is acting on the same point B. So moment of 100 Newton force about B will be 0. Now next we will go for the point C. Now point C is here, this one. And on the left side of this point C, we'll take the moment on the left side of this section. So there are the force, one is this RA, 100 Newton, and 200 is acting on the point C. So there is no moment because of 200. This reaction RA will produce clockwise moment, but their distance from A, C is increased. Clear? The distance will be increased. Now how much it is? 4. So RA into reaction at A, RA, that is 180.77 into 4 is your clockwise movement. And then this 100 kilonewton into perpendicular distance is 2 meters from B to C is produce anti-clockwise movement about C. So here this is minus, and your resultant moment at that point C is 523.08 Newton. After this, we'll go for the point D. This is point D. We'll take the moment, bending moment at D. Bending moment at D is equal to, see here, moment is a force into perpendicular distance. Now, all distance now with respect to D. So RA, whose distance from D is 2 plus 2 plus 1. From D, the distance will be now 5. So RA into 5. 100 distance from D, so 2 meter plus 1 meter, the distance is 3 meter of 100 Newton. So 100 into 3, and it is anti-clockwise. It is anti-clockwise. The next force is 200. This is also anti-clockwise, and whose distance between C to D is 1 meter. And the resultant moment at point D will be equal to 403.87 Newton meter. Now the last point, that is E, section at E. On the left side of section, if you take the moment, you'll get the calculations of all the forces and you'll get some value which will be equal to on the right side. So you can take either left or right of the section, and on the right of the section there is no force. But bending moment at E must be 0. Bending moment at E must be 0. So I calculated from the left side and the answer is 0. So you will take either left side of the section or right of the section, your answer will remain same. Now from these values, see, bending moment at A is 0, bending moment at B is 361.54, bending moment at C is 523.08, bending moment at D is 403.85, and bending moment at E is equal to 0. Based on this value, we'll draw bending moment diagram. Now see here, bending moment diagram, this is a beam. Parallel to beam AE, we'll draw a line, and we know that point A, this is point A, where the bending moment is 0. And the value of point B, the bending moment at point B is 361.51. We have marked over here. Then the value of point C 523.05 we mark here, and value of point D is 403.85 marked, and last is bending moment at E is equal to 0. Then in shear force diagram, there is a straight line. There is no slope between A to B, B to C, C to D, and D to E, as there is no very varying load acting along the beam. So in bending moment now, this will be joined by the inclined line. If in shear force there is a horizontal line, in bending moment it will be inclined line. So let's see here. C A to B is inclined line, B to C is inclined line, C to D is inclined line, and D to E is inclined. This is bending moment diagram, and this C2 530 523.08 indicate the maximum bending moment. This is indicate maximum bending. So like this, you can solve the numerical of shear force and bending. Thank you. Thanks.